Welcome to the video on quadratic functions. So there are three different equation formats for quadratic functions. There's the general form, which is f of x equals ax squared plus bx plus c, where you can easily find your y-intercept, which is 0, c, because if you plug in 0 for x, all that would be left is your c value for y. And then you can find your line of symmetry because it equals negative b, so this value, over 2a. The next form is your factored form. So f of x equals a, which is some constant, times x minus p times x minus q. This form is good if you want to find your x-intercepts, because your x-intercepts would be p, 0 and q, 0. So you can find these x-intercepts by setting your factored portions equal to 0. So x minus p equals 0, and x minus q equals 0. So x would be p, because you'd add p to both sides, and x would be q, because you'd add q to both sides. Finally, your vertex form is where f of x equals a times x minus h squared plus k. And this form is nice when you want to easily find your vertex, because your vertex will be at h, k. So this picture here is what a quadratic function looks like. It's often called a parabola. So this is your simple x squared function, where it has a vertex at 0, 0. Your y-intercept is 0, 0, and your line of symmetry is x equals 0. So first we're going to learn how to convert factored and general forms. So to go from general form to factored form, you would factor out your greatest common factor, and then find what multiplies to a times c and adds to b. So I like to use what's called the box method. So you draw a box, and in the top left corner, you'll put your ax squared value, and in the bottom right corner, you'll put your c value. So we want to find what multiplies to a times c and adds or subtracts to your b value. So once you find what those two numbers are, you'll put those numbers in these blanks, and then you'll pull the GCF from each row and column. So you'll pull your greatest common factor here and here, and this would be your first set in the parentheses, and then from your columns here and here, and that would be your second set of parentheses. So we'll start with this example. It says f of x equals 3x squared plus 3x minus 18. We have a greatest common factor of 3. So f of x equals 3 times x squared plus x minus 6. So we'll draw our box. In the top left corner, we'll put x squared, because that's our ax squared. In our bottom right corner, we'll have negative 6, because that's our c value. So we need something that multiplies to 1 times negative 6, so to negative 6, and it needs to add to our b value, which is going to be 1. So that would be a negative 2 and positive 3. So negative 2, positive 3, and we put our x's with them. So now we'll pull out our greatest common factors. So between x squared and 3x, our greatest common factor is x. From negative 2x and negative 6, we'll pull out a negative 2. Here in our first column, we can pull out an x, and in our second column, we can pull out 3. So this would become x minus 2 times x plus 3. So we have 3 times x minus 2, x plus 3 is equal to our f of x. So to go from factored form to general form, we'll simply distribute and combine like terms. So you can distribute this 2 first, or you can distribute your two binomials. We'll start with the 2. So when we do this, we get 4x plus 2 times x minus 4, and that'll become 4x squared minus 16x plus 2x minus 8. So that is going to become 4x squared minus 14x minus 8. And that's f of x in general form. Now we'll learn to convert between vertex and general forms. So to go from general form to vertex form, you have to do what's called completing the square. So to do that, you'll factor a out from your x squared and x terms. So we'll pull your a value out because we don't want anything other than a 1 in front of your x squared. Then we'll divide the new b value, which is b over a, by 2 and square it to create a perfect square trinomial. So this here is our perfect square trinomial because we have a squared value as our first and last, and then our middle value is our square root of the first times the last times 2. So this is your perfect square trinomial. So since we've added our a times b over 2a squared, we need to subtract that here at the end so that the equation is still equivalent to the initial one. So when we simplify that, we'll get that f of x equals a times x plus b over 2a squared plus c minus b squared over 4a. So we'll go ahead and do this example. So we have f of x equals 2x squared plus 6x minus 9. So we'll factor a 2 out from here. So we get f of x equals 2 times x squared plus 3x minus 9. Our b value over 2 is 3/2. So we'll say f of x equals 2 times x squared plus 3x plus 3 over 2 squared, because we're taking our b value and dividing it by 2 and squaring it. So then we still have our minus 9, and now we're going to have a negative 2 times this. So 2 times 3 over 2 squared. So this is 2 times this here. It's our perfect square trinomial, so it'll just become x plus b over 2. So x plus 3 over 2 squared. And then we have minus 9 minus 2 times 3 over 2 squared is 9 over 4. And then this 2 and 4 can simplify to a 1 and 2. So we have f of x equals 2 times x plus 3/2 squared minus 9 minus 9/2. So this is minus 18/2 minus 9/2. So it'll be negative 27/2. So here it is in vertex form. So to go from vertex to general, we'll also simply distribute and combine like terms. So we'll have 1/2 times x plus 4 squared is x plus 4 times x plus 4. So x squared plus 8x plus 16 minus 5. We'll distribute our 1/2, and that'll give us 1/2 x squared plus 4x plus 8 minus 5, which gives us our final f of x of 1/2 x squared plus 4x plus 3. So now we have our first IB practice question, which is no calculator. It says for y equals negative 6x squared plus 9x plus 15, A, find the y-intercept. So this is in general form. If x is 0, our y is going to be 15. So our y-intercept is 0, 15. Next it says find where y equals 0. So we're going to plug in 0 for y, so we get 0 equals negative 6x squared plus 9x plus 15. So to find our zeros, our factored form is the best form. So we'll start by pulling out a GCF. So 0 equals 3, and we're going to pull out a negative 3 because we don't want a negative in front of our x squared. So we'll have negative 3 times 2x squared minus 3x minus 5. Now we need to factor that, so we'll draw our box. In the top left corner, we'll have our ax squared, which is 2x squared. In the bottom right corner, we'll have our c value, which is negative 5. So it needs to multiply to 2 times negative 5, which is negative 10, and add to our b value, which is negative 3. So we'll have a negative 5 and 2. And then we'll put our x's there. Our GCF here is 2x. Here is -5. Here we'll have x. And right here we'll have 1. So this factors to -3 times 2x minus 5 times x plus 1. So our zeros are when each of these equals 0. So 0 equals 2x minus 5, or 0 equals x plus 1. We'll add 5 to each side here. So we get 5 equals 2x, and then when we divide by 2, we get that x equals 5 over 2. And here we just subtract 1 from each side and get that x equals -1. So y equals 0 when x equals -1 or x equals 5/2. Finally, we need to find the axis of symmetry. So to find the axis of symmetry, the best equation to use is our general form. So our axis of symmetry is x equals -b over 2a. So it'll be -9 over 2 times our a value is -6. So we have -9 over -12, which this becomes positive, and 9 over 12 simplifies to 3 over 4. So our axis of symmetry is x equals 3 over 4. So here we have our second IB practice question. It says, given the graph of f of x on the right, the equation of f of x can be written in the form of f of x equals x minus h squared plus k. Find h and k. So to do that, we need to figure out where the vertex is. So our vertex is here at point A, which is at 1, -9. So x has been shifted 1 to the right, so it's going to be -1, and then our y values are going down 9. So h equals 1 and k equals -9. And that's just from our vertex. Now it says the equation of f of x can be written in the form of f of x equals x minus p times x minus q. So our p and q values are going to come from our x-intercepts. So we have an x-intercept at -2, 0, and 4, 0. So p will equal -2, and q will equal 4. And you could swap that around because it's just being multiplied by each other. But your p and q values will be -2 and 4. Now it says find the y-intercept. So if we look at our graph, our function hits the y-axis when y equals -8. So it'll be 0, -8 is our y-intercept. And that's all for this question. So in summary, we have some important equations. The general form for quadratic functions is f of x equals ax squared plus bx plus c, where your y-intercept is 0, c, and your line of symmetry is -b over 2a. Your factored form is f of x equals a times x minus p times x minus q, where your x-intercepts are p, 0 and q, 0. Your vertex form is f of x equals a times x minus h squared plus k, where your vertex is h, k. To go from general form to factored form, you use the box method. To go from factored form to general form, you distribute. To go from general form to vertex form, you complete the square. And to go from vertex form to general form, you'll distribute. That's all for this video. Thank you for watching.